Good morning everyone, I hope you're well. In today's lesson we're going to be learning how to calculate the mean from a frequency table. For us to be able to do that, first of all we need to be able to calculate the mean from a list of data. Right, so it's a very simple process. All I need to do, so for my 1, 2, 4, 5, 6 and 13, I'm going to take the sum of all these pieces of data first of all. So that simply means I just need to add them together. Okay, so once I do that, I'm going to divide it by the amount of pieces of data that I have. So I have 1, 2, 3, 4, 5 pieces of data. Therefore, I take the sum of them and I divide by 5, and that gives me a mean of 6. So the mean is a type of average. So throughout this lesson, I'd like you to follow this reflect, expect, check process. So this simply means that we're going to be thinking mathematically as we work through a task. So for example, compare my question with the one I'm about to give you now. So the first thing we need to do is reflect. What has changed? It was a very similar question. It uses the exact same numbers, apart from I've just added on a 20 on the end of your question. So now I need to expect. So how will this answer compare to my previous one? Alright, so there's a few ways you can look at this. One thing you can think of, so if I make a prediction now, I could say, well, because I've added on one extra number, instead of dividing by 5, I'm dividing by 6. So one prediction I could make is that the mean will get smaller because instead of dividing by 5, I'm now dividing by 6. Alright, so the last thing I'm going to do is I'm going to check. I'm going to work it out. Does my answer match my expectation? So finding the sum of all of these pieces of data, and I'm dividing by 6 now instead of 5. Typing this in on my calculator, I actually get 8.3. So my prediction was wrong. So let's think, why was my prediction wrong? Well, I added on a 20, so the number I added to this list of data, it was actually larger than the original mean. So if I add on a number that's larger than the original mean, it's kind of intuitive to think, well actually, even though I'm dividing by a larger number, I've added on a larger number to the original list of data than the mean. So my mean has actually got greater because it's increased the average. So the new average is higher because it's got higher numbers on average, because 20 is higher than 6. Right, so as you work through this next task, I want you to follow this reflect, expect, check process as you follow through. Alright, so in your rough books, please could you work your way through the sequence of questions, so calculating the mean for each piece of data. Make sure you're making those predictions as you go along, because it'll be a lot more engaging if you try and predict the answers and make some expectations. Give yourself around 10 minutes, so please pause the video, and once you're ready for the solutions, unpause the video in 10 minutes time, and I'll give them to you. Okay, so here are the solutions to that first task. Alright, so in today's lesson we're going to be focusing on frequency tables. So we've looked at mean from a list of data, but how can we talk about the mean from a frequency table? Well, first of all, let's think about what this table could represent. So let's focus on this first row. Could you come up with a sentence that describes what's happening in this first row? So what does this first row actually mean? What does this 1 actually mean? I'll give you a chance to think about that. So that 1, so that means there is one person who is 7 years old. So the frequency is like the number of people in this context, and age is obviously how old they are. So just like before, what would this second row actually represent? So could you write a sentence that describes this the second row? So what does that 4 actually represent? So I'll give you some thinking time. Right, well that 4 just means that there are 4 people who are 8 years old. So that's how we read off a frequency table. But we need to talk about the mean here. So for us to calculate the mean, just like before, we had like a list of data, right? So getting a list of data from this table, so I have my 1 7-year-old, I have 4 8-year-olds, so 4 8-year-olds there. I have 2 9-year-olds and 3 10-year-olds. So actually, when you think about it, when you have a frequency table like this, you could just list it out as a list of data, and then using the process as before, we just find the sum of all these pieces of data and we divide by how many pieces of data we have. So we have 10 pieces, and that gives us a mean of 8.7. But there must be a quicker way than that, because in a GCSE exam, I'm not going to be listing out a massive list. What if the frequency was something like 60? I'm not going to write out a list of 60 numbers, am I? So there is a quick way, and I'm going to talk you through it now. So first of all, let's think about what the mean actually means. The mean would be the total sum of the ages divided by the total amount of people. Finding the total amount of people, that's the easiest bit because you just add up the frequency, don't you? So just adding up my frequency, finding the total frequency, I have 10. So I have my denominator, but so just think, what's a quicker way to find the total sum of the ages without having to list out every single number? Well, all I'm going to do, I'm going to find the total sum of my 7-year-old's ages. So I have one 7-year-old, therefore we have 7 years in total. If I have 4 8-year-olds, so I just do 8 times 4 to get 32, because 4 8-year-olds have a combined age of 32. 2 9-year-olds have a total age of 18. 3 10-year-olds have a total age of 30. So now all I'm going to do, I'm just going to add up the sum of all of their ages. So adding it up, that gives me 87. So now a very quick calculation to find the mean. I'm doing 87 divided by 10 because I've kind of like created a formula for myself. So it's the total sum of all the ages divided by how many people I have. Alright, so just like before, please could you make a quick prediction? So have a look, how does my question compare to your one? Okay, so you might notice that, well, all my frequencies have just doubled. Alright, so I want you to make a prediction out of that. How will your answer compare to my one? And then you're going to check it, you're going to work it out. So does your answer match your expectation? Please can you pause the video and have a go at this question, and so please use your best books. So this should take you 2 or 3 minutes. So pause the video now, and when you're ready for your solution, unpause the video. Alright, so for your one, your total frequency is 20. So instead of 10 people, there are now 20 people. And then the total sum of the ages should have been 174. Alright, so because everything's been doubled, does that mean that my mean has been doubled? Well, actually, no, it stayed exactly the same. Because both the total sum of the ages have doubled, and so has the frequency. So in a division problem, if you double both the numerator and denominator, the answer stays the same. You could think about these as equivalent fractions, can't you? So the mean is still 8.7, it stayed the same. Right, so continuing to follow this process, please could you work your way through this sequence of questions. I'd say this should take you about 15 minutes. So pause the video, take 15 minutes to work through this, and after 15 minutes you can check your answers and continue with the video. Okay, so your first 4 solutions are as follows. And here are your answers from 5 to 8. Alright guys, so new style of question. Calculate an estimate for the mean for a frequency table like this. So first of all, think, how is this frequency table very different to the one that you've just seen? Well, for this one, I have group frequency. So it's not saying I have 3 people who weigh 8 kilos. What does this first row actually mean? Well, this first row means 3 people had a mass of between 0 and 8 kilos. What would this second row actually mean? What does this 6 represent? Well, this 6 represents, well, there's 6 people who had a mass of between 8 and 16 kgs. So it's not actually giving us any precise information. It's more vague, isn't it? It's saying 6 people were around this kind of class interval. Right? But what if they asked us to calculate the mean from this frequency table? Well, in all honesty, we can't calculate the mean from this because we don't know the actual values. We don't know the mass of these people. Like all we've got is something rough. We just have a class interval. Okay, so they won't ask you for the mean. They'll ask you to estimate the mean. Right? So that means if we're estimating from a group frequency table like this, what I'm about to say is very, very important. What you've got to do, you've got to take the midpoint of each class. So, for example, this first row, we don't know exactly how much these three people weigh, But our best guess is to just say, well, 3 people had a mass of 4 kilograms. Why have I chosen 4 here? Well, 4 is the midpoint of 0 and 8. It's perfectly between 0 and 8 on a number line, so I'm going to choose 4 as my midpoint. So I'm estimating. So if I don't know, I'm just going to take the middle value, and that's my best guess effectively, and that's the best way I can estimate. So what I'm going to do, instead of what I've done last time, so now I'm going to do my frequency times by the midpoint. So I'm effectively saying, well, if 3 people had a frequency of around 4 kilos, so I'm taking the midpoint, that would give me a combined mass of 12, because it's 3 times 4 is 12. So I'm going to continue that process. Well, if 6 people had a mass of around 12 kilos, because I'm taking the midpoint of this class interval, I'm doing 6 times 12 gives me 72. So following on, I'm going to say 7 people had a mass of around 20 kilos, because 20 is the midpoint, so 7 lots of 20 is 140. And then finally 4 people, I'm going to say, had a mass of around 28 kilos. Okay, so these are very light people, maybe babies or children or something like that. Alright, so my total mass of all of these people is 336. So if you added up all their weights, you would get 336. Okay. So the mean, it would be the total mass, so all of their mass added together, divided by the total amount of people. The total amount of people, that's far easier to work out. I just add up the frequencies, so add up the number of people, that gives me 20. Therefore, I'm doing 336 divided by 20, and that gives me an estimate for the mean of 16.8 kilos. Alright, so just like before, I want you to use this reflect, expect, check process. I want us to be thinking mathematically about this. So first of all, we're asking ourselves, how does our question compare to the one that I've just done? Well, actually, everything's exactly the same, apart from the fact that my second class interval, instead of 6 people weighing between 8 and 16 kilos, no people weigh between 8 and 16 kilos. Alright, so in your best books, I want you to work this out, so make sure you copy the question, copy the frequency table. So you're going to pause the video, and this should take you 2 or 3 minutes again, and then once you're ready for a solution, unpause the video and we'll go through it. Alright, so for your one, your total mass of all of these people should have been around 264, well, should have been exactly 264 kilograms. Alright, so you do the frequency to this number, remember, you multiply it by the midpoint of every class. Okay, and then the total amount of people, that's the easy bit, just add up the frequency. Right, so I've got 264, and I need to divide it by 14, and that gives me 18.9 kgs when I round to 2 decimal places. In fact, no, I haven't, I've rounded to 1 decimal place here. So, can we think, why has the mean got larger? Did you predict that correctly? So why on average are we saying that this group of people had a higher mass on average than this group of people? Well, when you think about it, we've taken away this group of people who had a mass which was below the average. So the mean was 16.8. We've actually knocked off a load of these people who had a mass of below 16. So if you get rid of the people who weigh less than the mean, it follows that mean will actually increase in value. Alright, so last thing I want you to do today is work your way through this sequence of questions. So again, following that reflect, expect, check process. So for each question, I want you to make a prediction and see if you can use your previous answer to make you predict your next answer. You might be able to predict it exactly, or you might be able to just say, you know what, I think the mean's going to increase or decrease or stay the same, something like that. Alright, so please pause the video, work your way through these 10 questions, and then when you are finished, you can check your answers at the end of the video and unpause it. Alright. If you have any questions about anything we've done today, please don't hesitate to get in contact with me on Google Classroom. Alright, I hope you're all well. Thank you very much, and I'll see you later.